Well, hello, welcome to your feedback video session for the paper Depths in Chemistry, May 2024. Let's try and do it in less than 15 at attack. First question about water and ammonia. Hydrogen and oxygen have different electronegativities. Fact. What is meant by the term electronegativity? So you need to know this definition by heart. Is the ability of an atom, of an element, to attract a pair of electrons or a shared pair of electrons from a covalent bond. Okay, that is the definition you need to give. It's worth 2 marks. Don't forget. Then you had to draw and label a hydrogen bond. In the question, they tell you to include relevant dipoles and lone pairs. Do draw the relevant dipoles and the lone pairs. And when you do your diagram, it looks like this. Your H are delta positive, your O is delta negative, and the hydrogen bond, which has to be labeled, must be between the lone pair of electron on the oxygen and the delta plus hydrogen of the neighbor molecule. Okay, this will give you 2 marks. Explain why molecules of H2O are polar. Remember 2 conditions for a molecule to be polar. It needs to have polar bonds and the molecule needs to be non-symmetrical, which is the case with water. So the OH bonds are polar because O is more electronegative than H, and the molecule is non-symmetrical, it's non-linear, so the dipoles don't cancel each other out. There is an overall dipole. Okay, I'm not entirely sure what would give you the 4 mark, but go for everything. One unusual property of H2O is that ice floats on water. Explain why ice has a lower density than water. So this is caused by the hydrogen bonds. The hydrogen bonds are longer than the normal London forces or permanent dipole-dipole forces of interaction between molecules of water. And so the hydrogen bonds are going to hold water molecules apart in an open lattice structure. It just means that it's going to push the molecule of water slightly further apart from each other than if there were not any hydrogen bonds. So yeah, this is what you need to give for 1 mark. They hold the water molecules apart in an open lattice structure, so the density decreases when it's a solid. Solid ammonia NH3 also contains hydrogen bonds. Fact. Suggests why solid ammonia has a lower melting point than ice. So if you draw your dot and cross diagram for an NH3 molecule, you will notice that there is only 1 lone pair around the nitrogen atom, but there are 2 lone pairs around the oxygen atom in water. Therefore, the NH3 can only form 1 hydrogen bond per molecule, whereas H2O can form 2. Therefore, more hydrogen bonds must be overcome or broken in water than in ammonia, or in ice than in solid ammonia, so more energy is needed to do so, and this is why water has a higher melting point than ammonia. Don't forget to talk about the energy needed to overcome forces of attraction. When ammonia dissolves in water, ammonium ions NH4 plus are formed. Draw a dot and cross diagram to show the bonding in an NH4 plus ion. Show the outer electrons only. So we've talked about the dot and cross for an NH3. So you have 3 covalent bonds and a lone pair around the nitrogen. To form NH4 plus, you're going to form a dative covalent bond between the nitrogen and the hydrogen. And these 2 electrons are coming from the nitrogen. When you draw the dot and cross diagram, please don't forget the positive charge of the ion and make sure you have a dative covalent bond between one of the hydrogen and the atom of nitrogen. 2 marks, it's worth it. Outline how you would test for the presence of NH4 plus ions in the solution. You need to know this one by heart. So you're going to add some NaOH, you're going to warm it up. A chemical reaction will take place forming ammonia, and ammonia is an alkaline gas. So if you put damp litmus paper, it will turn blue, or you can put damp universal indicator paper or pH paper, which is also going to turn blue. Okay, so add an AOH, warm up gently, and either pH paper or red litmus paper turns blue. The students heat 11.5 grams of hydrated zinc sulfate with 7 water of crystallization. To remove all the water of crystallization, calculate the mass of anhydrous zinc sulfate that would be obtained. So first you're going to calculate the number of mole of hydrated zinc sulfate in 11.5 grams by dividing the mass, 11.5, by the molar mass of your hydrated salt. you should find exactly 0.04 mole. If you evaporate all the water, you will be left with exactly 0.04 mole of zinc sulfate, anhydrous. Yes? And then if you have the number of mole, you can calculate the mass by multiplying this number of mole by the molar mass of zinc sulfate, and you should find 6.46 grams. Next question, the question about periodicity and the reaction of some group 2 metals. Periodicity is the repeating trend in properties of elements across the different periods in the periodic table. Compare the table below with the electron configuration in blocks. So beryllium has 4 electrons, so it's going to be the 1s2, 2s2. Magnesium is 12 electrons, so 1s2, 2s2, 2p6, 3s2. They both belong to the s block. Fluorine has 9 electrons, so the electronic structure will be 1s2, 2s2, 2p5. Chlorine has 17 electrons, 1s2, 2s2, 2p6, 3s2, 3p5 belongs to the p block. Here's your answer to explain why electron configuration is an example of a periodic trend. So if you look at the question, periodicity is a repeating trend in properties of elements across different periods in the periodic table. So what you could say is the element of the same period, so period 2, they both have electrons, or the higher energy level being filled up by electrons is the same. For period 2 is going to be the second energy level, is going to be the third energy level for group 3, for period 3, sorry. If you look at the groups, we can notice that all the elements of the same group have the same sublevel being filled up with the same number of electrons. So NS2 for group 2 and P5 for group 17. Okay, so elements of a group have the same last subshell filled up with the same number of electrons, and the element of the same period have the same energy level filled up with electrons. And that should give you the 2 marks. Mg forms 2+ ions, but Cl usually form -1 ions in their reaction. Explain why. So magnesium has 2 electrons in its outer shell. You're going to lose 2 electrons to have the electronic configuration of a noble gas. Chlorine has 7 electrons in its outer shell. It will gain 1 electron to have the electronic structure of a noble gas. So Mg loses 2 electrons to have the electron configuration of a noble gas. Chlorine gains an electron to have the electron configuration of a noble gas. Magnesium reacts with oxygen in the air. Fact. Write the equation for this reaction. Magnesium plus oxygen makes magnesium oxide. 2Mg plus O2 form 2MgO. You don't have to write down the state symbol, but if you had to, magnesium is a solid, oxygen is a gas, magnesium oxide is a solid. The reaction between calcium and hydrochloric acid is a redox reaction. Explained in terms of electron transfer why the reaction shown in equation 2.1 is a redox reaction. It was about electron transfer, about electron gain and electron lost. It's tempting to use the oxidation number, but that would not give you any marks because it's about electron transfer. So calcium in this reaction has lost 2 electrons to form Ca2 plus and CaCl2. Therefore, Ca is oxidized. Remember, oil rig oxidation is a loss of electron. Hydrogen, on the other hand, has gained an electron from H plus in HCl to H2. Therefore, hydrogen is reduced. So electrons are transferred from calcium to hydrogen. It's a redox reaction. The reaction between calcium and hydrochloric acid is a redox reaction. Blah, blah, blah. A student planned to add 0.01 mole of calcium to 120 centimeter cube of 0.1 mole per centimeter cube HCl. When the student carries out this reaction, they are surprised that all the calcium reacts despite being in excess of the HCl. Show by calculation that calcium is in excess of the HCl. Suggest the reason for this unexpected result. So step 1, you're going to have to calculate the number of mole of HCl you actually have. By doing the concentration times the volume, you should have exactly 0.012 mole of HCl. So if you have 0.012 mole of HCl, you will need half of that mole of calcium, so 0.006 mole of calcium. But in reality, you have 0.01 mole, which is more than 0.006. Therefore, calcium is in excess. So the excess calcium may have reacted with water, that's a possibility, to form calcium hydroxide and hydrogen. And that's why you are left with no calcium in the end, because you have a side reaction. I hope that makes sense. Next bit, complete the graph by adding points for the missing values of B, boron, and magnesium. Some of you forgot magnesium, come on. So first ionization energy, remember the general trend is going to go up across a period with two exceptions between group 2 and group 3 and between group 5 and 6. Okay, that's because you are removing an electron from the p orbital in group 3, whereas it was group s orbital in group 2. So it's a slightly higher energy level, so it's easier to remove it. So you're going to have a slight drop between Be and B. And for magnesium, you have to look at what's happening compared to beryllium, because you know that when you go down a group, down group 2, the first ionization energy is going to decrease because you are increasing the electron shielding the atomic radius. So the point for magnesium has to be below beryllium and it has to be higher than sodium. So anywhere between 500 and 900 would give you the mark. Write an equation including state symbol to represent the second ionization energy. So it's the loss of the second electron. So you start from B plus and you end up with B2 plus an electron. B plus and B2 plus are gaseous. Make sure you put B, not BE. There's some weird mistake there. Next, enthalpy changes of reaction can be determined by experiment. What is meant by the term enthalpy change of a reaction? This one is a bit strange. The definition, the official definition for OCR is the enthalpy change of a stated reaction. Weird. I prefer the one from the textbook, which is the enthalpy change that accompanies a reaction in the molar quantities shown in a chemical equation. Okay, this is the, I would go for this definition for a mark. Next bit, a student carries out an experiment to determine the enthalpy change for the reaction between zinc and copper nitrate. So they followed the method, had 100 centimeter cube of solution of copper nitrate, measured the temperature, add a lot of zinc, stir the mixture and record the maximum temperature, calculate the enthalpy change of reaction. So first assumption we need to make that the density of copper nitrate solution is the same as the density of water. So we actually know the mass of solution because we have the volume, not the mass. Then we're going to assume that the specific heat capacity of copper nitrate solution is the same as water. So we can calculate the energy change. So the energy change is the mass of solution times the specific heat capacity times the change in temperature. And if I use the values, I found 7,774.8 joules plus the energy change or the energy gained by the water, so lost by the system. Then I need to calculate the number of mole of copper nitrate used by doing the concentration times the volume. And I find exactly 0.05 mole of copper nitrate. And to calculate the enthalpy change of reaction, I need to do minus the energy gained by the water divided by the number of mole of copper nitrate, which is minus 155.5 kilojoules per mole. To improve the results, you could use a lid and insulation around the beaker to increase the accuracy. The student modified the experiment using 50 centimeter cube instead of 100 centimeter cube. The concentration stays the same, and the value of delta RH of the experiment is the same as the previous one. And that's because if you divide the volume by 2, you divide the mass of solution by 2, but you also divide the number of mole by 2. Therefore, the energy transferred to the water is divided by 2. Because the mass of the solution is divided by 2, the changes cancel each other out. Okay, the value of m here and the value of n here are both divided by 2, so these two cancel each other. Delta H is exactly the same, and normally the temperature change should be exactly the same. Question 4. Let's draw a Boltzmann distribution curve and to show why catalysts increase the rate of reaction. So we have this beautiful curve, and you're going to have a line for make sure energy is on the x-axis and number of particles with a given energy on the y-axis. Then you're going to add the activation energy without a catalyst, EA, and the activation energy with the catalyst, EC. So because the catalyst increases the rate of reaction by providing an alternative pathway of lower activation energy. So more particles have an energy higher than the activation energy with a catalyst than without. You have a larger area below the line with EC compared to EA, so you have more frequent successful collisions. I will see you in a second for part 2 of this video.